All right, so just a reminder that tomorrow your graphs of cotangent and cosecant are due, and that's in everybody thing. Okay? That's for everybody. Those are due tomorrow. If you've got them done already and you want to put them in your grading teacher's basket today, have at it. Okay? Okay? But otherwise, those are due tomorrow. Okay? So let's talk a little bit here about inverse functions. Okay? Because that's what we're going to start today. We're going to start the inverse functions for the trig functions. Okay? Now, in a prior math class, you learned that when you're creating the inverse of a function, you switch the x and the y. That's how we create inverse functions. We switch the x and the y, and then normally we would solve it for y then again, and then that gives us our inverse function. Okay? So here in this first one, y equals 3x, if I switch the x and the y, I get x equals 3y, or y equals x divided by 3. And then blue and black are inverses of each other. I was going to say inverse functions, which they are. They're inverse operations. If our original function was y equals x plus 7, I would switch the x and the y. X equals y plus 7, or that would become y equals x minus 7. So on a graph, if we graphed those functions, they would be inverses of each other. Their x's and y's would be switched all the way through. Gets a little trickier when we get into a little more complex type ones. Okay? But again, the process stays the same. If I've got y equals x squared, then that becomes x equals y squared, or y equals plus or minus the square root of x. Okay? In an exponential type function, again, we could switch the x and the y. Or we could switch forms with it. With exponentials, we solve them using logarithms. Okay? With logarithmic functions, we solve them using exponentials. So we could write this as y equals the log base 3 of x. What I want to focus in on today is I want to focus in on the trig function of sine. We'll do sine today. Tomorrow we'll do cosine and tangent. And then Monday, Tuesday, we haven't quite figured out what we're going to do with that day yet. Okay. So, again, I switch my x and my y. So this becomes x equals the sine of y. But now, you also have learned back when you were in geometry that if you needed an angle finder, you used the inverse sine function. create a graph of the sine function. Okay. So where does sine start? If I'm making a sine graph. Let me move this down a little bit. Where does sine start? In the middle, right? At 0. Okay. Then it goes up or down? Up. Okay. So it goes up, comes back down, and ends like that. Correct? If I were to continue that the other way, actually let me do some fancy-dancy stuff. Let me go copy. Fancy-dancy stuff. Don't act like you're not impressed. Huh? Now let's put some labels in there with it too. So horizontally, this would be 0. This one would be pi over 2. Here, pi. Here, 3 pi over 2. And here. All right, let's go the other way. Here, negative pi over 2. Here, negative pi. Here, 3 pi over 2. And here, negative 2 pi. Love it. Oops, I got to move my 0. Here, here, positive 1. Okay. All right, love it. Excited for it. Can't get enough of it. Okay, so I am going to go like this. I think I got everything. The only thing I didn't get was the 2 pi. I think everything is in a box, yes? Hold on, I want to group it first. Now I want to copy it. There we go. You'll see why in a minute here. Okay? All right. So, now, let's talk inverse. Let's talk the inverse. Okay? So, if I am creating the inverse, that means then that I am, again, switching X and Y, right? Side note, very bright water bottle. Love it.
Thanks.
Okay? Okay? So that means what switches on a graph? What also would switch? If I'm switching X and Y, what switches on a graph? My axes switch, right? Okay? So that creates now, so for me, I'm going to go like this. Okay, so there is my graph. Make sure I'm on the right one. Okay, so there's my graph, right? So if I switch, so my x-axis, which is my horizontal axis, becomes my y-axis, right? So it ends up looking, extend the page down there, okay? So it ends up looking like this. Now, let me see if I can. I think I got to ungroup it now. Group, ungroup. See, now I got to spin on. Whoa, tap the brakes. I'll just rewrite them. Okay. So this now becomes my pi over 2. This now, oops, see, I went the wrong way. This now becomes pi. Three pi over 2 and 2 pi. Negative 1 here, positive 1 there. Negative pi over 2 there. Okay. Whoops, wait, tap the brakes. Hold on. Stop, 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 stop. I did spin it the wrong way. Wait. Hold up. Hold the phone. Good intentions, bad results. It went the wrong way. It didn't just spin. Okay? So, if I'm on my unit circle, I'm at 0, 0. Actually, I shouldn't say that. So if I'm on, well, yeah, I can look at signs. So if I'm at 0 for my angle, I'm at 0 for my sine value, correct? So we'll flip those, still at the origin. If I go up to pi over 2 would be at 1, which means at 1, I would be at pi over 2. So it would come through like that. I went too far on that one. Is that what it looked like? And I'm just getting all crazy in the head? Or is that different? It's different? Okay, good, because this is how it should be. Okay? And then, so I'd go out to here, back to here, so it'd be right there, and go to here, there. Okay? Sorry. I thought I was going to be all nice and cute and get you exactly, and it didn't work. Okay, so I'll give you a second to adjust your graphs. Okay. Now, what's wrong with this picture in terms of functionality? And what about it? It's not a function. Okay? It's not a function. So it doesn't work in terms of our mathness. Okay? So if I want to make the inverse sine be a function, I first need to have some notation for it. I need function notation for it. So my function notation, or what the function looks like, is, so my original would have been y equals the sine of x. Okay? So that's my original. Okay? My inverse is going to be y. So if I go x equals sine of y, that would be y equals the inverse sine of x, which you've seen. You saw that one in geometry. We're going to add one here now. That means the exact same thing. If we have arc sine of x, that is also the inverse. And both of those stand for inverse. Okay. Now, because my original was not a function, this one down here, not a function, I'm going to have to restrict this one to make it be a function. Okay? Now, in my original sine function, my domain is all real numbers. My range is from -1 to +1. Agree with that? Okay? Which means then, so up here, my domain was all real numbers. My range was from -1 to +1. Okay? Down here on my inverse, my range, my domain is what? -1 to 1. Those switch. And my range then would be all real numbers. Okay? So fast forward now, where can I find my answers when I'm dealing with the inverse sine function? Well, my domain is still from -1 to +1. So I need to hit every x value from -1 to +1. Oops, that's not a straight line. OCD kicking in. So I need to go from 1 to -1. Okay? And as long as I'm at or around the origin, let's take, and I'll put it in this color now. I'm going to take, oops, down too far. That looks bad. That looks better. I'm going to take that part of the curve. Which, so now on your inverse, on your new inverse sine curve, because we screwed up on it, or I screwed up on it, that goes up to pi/2, correct? And down to -pi/2. So we've restricted our range to make it be a function. Okay. Now, the range in any function is the output. It's the answer that you want, correct? Okay. Inverse trig functions find angles. Okay. So the inverse sine function is going to find angles where on the unit circle? where is the range, or where are the angles on the unit circle from negative pi over 2 to positive pi over 2? Which half of the circle? Left half? Right half? Top half? Bottom half? We're on the right half of the unit circle. Okay. From negative pi over 2 to positive pi over 2. We're on the right half of the unit circle. Okay. Now that I've made that as clear as mud for you, let's just get to work doing this stuff. Okay? So remember, we are stuck when we're using the inverse sign or the arc sign. We are limited to the right half of the unit circle. So you should have all your unit circles now because we're going to use those. So what I'm thinking when I see arc sine of 1/2, okay? I'm thinking to myself, where on the right half of the unit circle is sine equal to 1/2. That's what I'm thinking. So I stick to the right half of the unit circle. Sine is x or y on the unit circle? It's the y. So I'm looking at the y coordinate. Where is it 1/2 on the right side of this unit circle? Pi over 6, right? Okay. So this is pi over 6. The arc sine of 1/2, or the inverse sine of 1/2, is pi over 6. You're getting an angle. You're finding an angle. Inverses find angles in trig. Okay. Next one. Again, inverse sine, right half of the unit circle. Where is sine equal to negative 1/2? I want to say 11 pi over 6 because that's where it happens, right? And you're going to want to say 11 pi over 6. But remember, our angles have to be in between negative pi over 2 and positive pi over 2. So 11 pi over 6 doesn't fall in that range, so instead we write it as negative pi over 6. Because negative pi over 6 is in this range of answers. Okay? What I would like you to do now is I would like you to find me these four. The inverse sine of square root 3 over 2, the arc sine of 2, the arc sine of 0, and the inverse sine of negative 1. So, on the right side of the unit circle, sorry, I gotta bring my unit circle with me so I can see it. Okay, right side of the unit circle. By the way, Mr. Erdman left you guys all a note. Okay, 3 square root 3 over 2. I get pi over 3. Agree? For number 3 here. Yes? Square root 3 over 2 is pi over 3. Arc sine of 2. Where on the right side of the circle is sine equal to 2? To 2. Nowhere, because sine's got to be between -1 and +1, right? So nowhere on the right half of the circle is sine equal to 2 because it's not possible. Right half of the unit circle, where is sine equal to 0? At 0. Right half of the unit circle, where is sine equal to -1? I'm thinking 3 pi over 2, right? But 3 pi over 2 doesn't fall in my range. So that becomes -pi over 2. Okay? Now, the question has been posed earlier today. What if this were a test question, let's say, inverse sine of -1, and you gave the answer of 3 pi divided by 2? Would you be right or would you be wrong? What do you guys think? Are you right or are you wrong? You're wrong, because it's not in the range that inverse sine has to be. Okay? So yeah, we're literally talking the exact same spot, okay? But one of them is legal, one of them is not. Okay? -pi over 2 is illegal. Okay? Anybody gone tomorrow for DECA districts? If you are, come pick up a packet for tomorrow. If you're not, you'll get it tomorrow in class. This is due on Monday, Tuesday, whichever day you have class. Or if you're not going to be here tomorrow. Okay, what? You don't have class until Tuesday, so you're okay. I thought you had class on Tuesday with me.